Caffeine may be famous for its morning magic, but what it does inside your cells is even more impressive than what it does to your to-do list. Beneath the alertness and focus lies a complex biochemical story, one where a simple molecule, derived from a bean, travels through your bloodstream and ends up in the control rooms of your cells, the mitochondria. Here, caffeine doesn't just rev up your mental engine, it helps protect, regulate, and optimize the very machinery of life. At the heart of caffeine's cellular effects is its ability to influence mitochondrial function, and that's a big deal. Mitochondria aren't just the powerhouses of the cell, they're dynamic regulators of aging, inflammation, and metabolic efficiency. With age or chronic stress, these little organelles become sluggish, leaky, and less capable of producing ATP, the energy currency your body depends on. This is where caffeine enters like a molecular coach, nudging mitochondria to shake off the cobwebs and get back to work. Studies show that caffeine can increase mitochondrial biogenesis, essentially encouraging the cell to make more mitochondria. This effect is partly driven through the activation of AMPK, an energy-sensing enzyme that tells the cell when it's time to upgrade its energy infrastructure. When AMPK gets activated, which caffeine helps with, it flips genetic switches that turn on PGC1A, a master regulator of mitochondrial production and function. So caffeine doesn't just push the existing mitochondria, it orders up more of them, freshly built and ready to work. But caffeine's cellular support doesn't stop there. It also helps reduce oxidative stress, the biochemical equivalent of rust that builds up when energy production goes wrong. When mitochondria produce ADP, they also leak a bit of reactive oxygen species, ROS, tiny but toxic molecules that can damage DNA, proteins, and lipids if left unchecked. Too much ROS, and the cell starts to unravel. Too little, and you lose necessary signals for adaptation and repair. Caffeine appears to strike a delicate balance. It acts as a mild pro-oxidant at low doses, triggering a hormetic stress response that actually strengthens the cell's antioxidant defenses. It's like a tiny fire drill for your mitochondria, enough to make them upgrade their systems without causing damage. This includes upregulating antioxidant enzymes like superoxide dismutase, SOD, and glutathione peroxidase, which help mop up excess ROS and protect cellular structures from long-term harm. Even more intriguingly, caffeine may modulate gene expression related to inflammation, energy metabolism, and cellular repair. It does this not just through AMPK, but also via adenosine receptor antagonism. Adenosine is a neuromodulator that promotes sleep and dampens neuronal activity. Caffeine blocks its receptors, which indirectly affects intracellular signaling cascades linked to gene transcription. This can lead to downstream effects such as enhanced wakefulness, but also reduced expression of pro-inflammatory genes and increased expression of genes involved in metabolism and resilience. In brain cells, this effect is particularly valuable. Caffeine seems to help preserve neuronal mitochondrial function, limit neuroinflammation, and possibly reduce the buildup of toxic proteins like beta-amyloid, one of the culprits in Alzheimer's disease. In muscle cells, it supports endurance and recovery by enhancing mitochondrial efficiency and reducing fatigue. And in the liver, caffeine helps regulate lipid metabolism and protect against fat accumulation and insulin resistance. So from molecules to mitochondria, caffeine acts like a multitasking biohacker, fine-tuning energy production, curbing oxidative chaos, and helping cells perform at their best. It's not just keeping you awake, it's keeping your cells young, agile, and ready to face metabolic challenges. Of course, this doesn't mean the more, the better. There's a sweet spot. Too much caffeine can lead to stress, mitochondrial overload, and a cellular rebellion in the form of jitteriness, anxiety, or poor sleep. But when consumed in moderate amounts, think 1 to 3 cups a day, caffeine offers a surprisingly elegant blend of energy stimulation and cellular maintenance, proving that sometimes the simplest daily rituals are also the most sophisticated forms of biosupport. So the next time you sip your coffee or tea, just remember, you're not just waking up, you're giving your mitochondria a pep talk, one molecule at a time.